Okay, we're going to go into our third question of the day, and this actually comes from the November 2017 matric exam. All right, and this one is a little bit more difficult. So you'll see there are two objects and they're passing one another, and so now it gets a little bit more difficult. All right, so let us have a look at the question. Once again, I would like you to actually take a photo of the question. I will read through it and then obviously extend the page so that you can take a photo of the actual diagram, because that helps us to interpret the question as well. So I just find if you've got the question in front of you, it just helps it makes it a little bit easier to understand what we are doing. All right, let's have a look. Stone A is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. Ignore the effects of air resistance. Now that is always such an important fact to remember, always to ignore those effects. At the same time, or at the same instant that stone A is projected upwards, stone B is thrown vertically down. Gosh, okay, so stone B is thrown vertically down at the same instant that stone A was projected upwards. And stone B is projected down from the same height at an unknown speed v. Refer to the diagram below. When stone A reaches its maximum height, the speed of stone B is 3v. Okay? At the instant stone A passes its initial position on its way down, stone B hits the ground. My goodness. So there's a lot of information to interpret. All right, so I hope you've taken a photo of that. So now I'm going to show you the diagram. So please take a photo of the diagram as well. And there's the diagram. Okay. Let us have a look at the first question. It says, calculate the time taken for stone A to reach its maximum height. All right, so once again, we've done something similar. Now, once again, we must now select a direction as positive or negative. All right, so let us take up here as the positive direction. All right, so if we take up as positive, all right, V final equals V initial plus G delta T. Now, when stone A reaches its maximum height, its final velocity is going to be 0. So I'm throwing the object up. It's got an initial velocity, and the initial velocity of the stone was 12 meters per second. Final velocity at the top of the motion here is 0. Now, because I'm taking up as positive, we know that G is acting down, so it will be negative 9,8. All right, so let us see what we can do. So we want to calculate the time. So final velocity was 0, nice and easy. Initial velocity was 12. G is minus 9,8. So please, please, please don't forget about the direction. All right, so to solve, we get minus 12 equals minus 9,8 delta t. Therefore, delta t equals negative 12 divided by negative 9,8. And now we need our faithful calculator. It's not letting us down today, so 12 divided by 9.8, and that is equal to 1,22. So the time in the air is 1,22 seconds. So that was the time taken for the object to reach its maximum height. That was for stone A. So stone A was in the air for 1,22 seconds. Okay, great. Let us look at the next question. Next question says, when stone A reaches its maximum height, the speed of stone B is 3v. Calculate the speed v with which stone B is thrown downwards. So obviously you can see that this is going to be your higher order question. All right, so let us have a look at the information that was given to us. So looking in the upward direction we took as positive. So let us have a look what information we have for stone B. So V in the final equals V initial plus A delta T. So it says when stone A reaches its maximum height, stone B's final velocity is 3v. So it's 3v. What was stone B's initial velocity? It was v. But now don't forget, we took up as positive. Stone B is moving down. So its initial velocity down will be negative v. Its final velocity in the downward direction is minus 3v. So this must be minus and this must be minus. Gravity was obviously minus 9,8 delta t. Now what is delta t going to be? So remember they said stone A reaches its maximum height. And so we're going to use the time it took for stone A to reach its maximum height. That is the time it took for stone B to go from V to 3V. So the time we're going to use is 1,22 seconds. Okay, so the time is 1,22 seconds. Now it's actually not that difficult. So now we just need to solve. So we're going to get minus 3V plus V equals. Now we need our faithful calculator. So we're going to go 1.22 multiplied by 9,8, and that is going to equal 11,956. So it's going to equal minus 11,956. So let us just, we'll just leave it with that, it's fine. So minus 3b plus v, so that's going to be minus 2v equals minus 11,956. And now it's easy. Now we solve for v, and so v is going to equal 11,956 divided by 2. And there we go. And that is the initial velocity, 5,978 meters per second. We can round it off to 2 decimal places, so let us make it 5,98 meters per second. And it was thrown downwards. All right, and there we go. Not too bad. All right, so that was a level 2, level 3 question. So a little bit of thinking, more level 3 question. So a little bit of interpretation. So you had to take the time that you use for stone A and use it for stone B. So stone B's velocity increased from V to 3V in the same time that stone A reached its maximum height. So that was the connection that you had to make there. All right, great. Let us go into the next question. They say, at the instant that stone A passes its initial position on its way down, stone B hits the ground. Okay, so what can we get from that? And now they want us to calculate the height h. So remember, stone A went up in 1,22 seconds and it came down in 1,22 seconds. So this is referred to as time symmetry. So because we are ignoring air friction, all right, it's known as time symmetry. So the time it took for stone A to go up is exactly the same for it to come down to the same point from which it was thrown. So now the time that we need to work with is 2,44 seconds. All right, so that is the connection between stone A and stone B. All right, so let us have a look at how we can do this. They're wanting us to calculate h. So we're going to use our equation of motion. We've got time, so we're going to go delta y equals vi delta t plus a half g delta t squared. We're wanting delta y, okay? Now the initial velocity is what we've just calculated here. So remember, stone B was thrown down. So it's minus 5,98 multiplied by the total time now in the air. So it's 2,44 seconds plus a half. G is in the downward direction when we chose down as negative because up was positive. Sorry, I've run out of space. Multiplied by 2,44 seconds squared. And now we just have to put that all into the calculator and get the answer. All right, so let us go and do the final answer. So delta y equals, and please check me at home that I don't make mistakes, so 5.98 times 2.44 is equal to 14,59 1, 2, and don't forget the minus because it's negative times a positive, so it's a negative answer. And now here we're going to have a positive multiplied by a negative, so it's also going to be negative. So let's have a look. All right, so now we're going to have 2.44. So remember old school, times 2.44 equals that, times 9.8 equals that, divided by 2, minus 29,17. Minus 29,17. And so delta y, we just add them all together. And so it's going to be 14.59. I'm just rounding it off now to 2 decimal places. And plus 29.17. So in total, the total distance was 43. Oh, and I lost the number. It was too quick. 43,76. So it's equal to 43,76 meters. And there we go. And there we've got the height. All right, so when you got your equation of motion, we substitute in. So don't forget the direction. So obviously, if you've selected the direction and you forgot to put in the plus or minus, you're going to get a totally different answer. So just watch. With vertical projectile motion, direction, positive, negative, always check. And just remember, if you get a negative time, we can never go back in time, so you can't get a negative time. So go back and check. You selected one of your signs incorrectly. All right, so that's always a hint. So if you get a negative time, go back and check. All right, so let us have a look at the last question here. And it's probably going to be a graph. All right, so now they're asking you, label your graphs for, sketch velocity time graphs for the complete motions of stone A and B on the same set of axes. Label your graphs for the stones A and B clearly. Show the following on your graphs. The time taken for stone A to reach its maximum height. And when does stone A reach its maximum height? When its final velocity is 0. And show the following on your graph, the velocity with which stone B was thrown downwards with. And remember, stone B, his initial velocity was minus 5,98. So now we've got to be very careful with our graphs, okay? So you've got to draw them on the same system of axes. So we're going to have velocity in meters per second, and we're going to have time in seconds. So let us start with object A. So object A was thrown up at a velocity of 12 meters per second. So we can show it on our graph. It was thrown up at 12 meters per second. It reached its maximum height after 1,22 seconds, and then it returned and it went past. And it went further than what stone B, because it went up and it came down and fell through the height of the building. What did stone, so this is stone A. Now, what did stone B do? So stone B, we've got to start our graph at minus 5,98. And now it went faster and faster. So I need to extend my page a bit more here. All right, so what we're going to find for this one is that your graph is going to be slightly different. So now stone B is going to be there, all right? And it hit the ground. Okay, so let's try and do it a bit more accurately. So hopefully that looks like 2,44 seconds. And this is going to be for stone B. So I didn't use a ruler here, so it should be a nice straight line. Why is it a straight line? Because gravitational acceleration is 9,8. All right, so there we go. So always remember with vertical motion remember your direction, and then when you've selected those directions, they must be reflected in the graphs that you are going to be drawing. Great, we're going to